Alrighty, I believe I'm recording. What's going on, everyone? I have the AC in the back on, so sorry about that sound, but it's kind of hot in my room. But yeah, man, we're on day 44, I believe. 44. Oh, sorry, we just finished 44 yesterday. Let me switch my screen. We finished day 44. We're on day 45 now, so nice. Today, yesterday, I look a bit slacking here, so today we're gonna do hash maps, and guaranteed we're gonna finish all this today, all of these. So I don't know how long it's gonna take, but the goal is to finish all of it, so we can start doing something else the next day. We can do this. All right, man. Let's get straight to it. And yes, I didn't finish the red black tree bullshit. I'll do it later time. I just feel like that's like, I don't know, I did research on it and I feel like it's not a data structure that's really being asked in an interview, so not really gonna do it. But we're on hash maps. I don't know what happened. So just a little review of a hash map. It's a data structure that maps keys to values, so Bob to Ross, Pablo to Picasso. And yeah, just basically like a Python dictionary is an example of a hash map. See, you already know what a hash map is, so kind of makes sense, kind of doesn't. Still need to figure it out. While hash maps are simple to use, you're already proficient with Python dictionary. This is a bit trickier, right? So they're built on top of arrays. Thing is, with this section, there's no like video, so hash map Python DSA. Let's see if we can watch a quick video. Just have a good refresher. I don't think I want. These videos are long. Okay, whatever. I don't know. I just did a video, bro. It's not even that serious. I don't know this guy.
Imagine being able to build.
Man, we gotta watch a stupid ad, man. Hurry up. Skip.
Hey everyone. Today we are going to be starting a series by Python. Is a data structure that stores information called values and pairs them up with unique identifiers called keys. A simple example to understand this is a university GPA directory. Each student likely has a unique student ID, which is the key, and it has a respective GPA along with it, which is a value. Or think of a list of capital cities. If we make the keys countries, we can just look up the country to find the capital city, which is the value. Hash maps are useful for two main reasons. The first is, when working with big software systems, readability becomes incredibly important, and being able to customize keys can be quite helpful. The second is that hash maps allow for searching of specific values in O of 1 runtime, which is faster than arrays and linked lists, which have a search time complexity of O of n. Now you know what hash maps are and why they're useful. But let's dig a little deeper and understand how hash maps actually work. Hash maps are commonly built off of a predefined data structure like an array. Like hash maps, arrays do also have keys that store values. For arrays,
the index?
The key is a preset number called an index, which starts at 0. A hash map is created from an array through the use of a hash function, which takes in a custom piece of data that we want to assign to a key, like a country from our earlier example, and maps this data to an index on the array. These hash functions can get complex, especially as they have to tackle issues that come up when mapping data to indices. The most common issue that comes up is called a collision.
Well, guys, I got an important call from my dad. If you see this, skip 5 minutes from this. It's 5 minutes now. skip to 8 minutes into this video. I'm not trying to cut anything, so I'll cut. Let me give me a sec. Alright guys, I'm super sorry if you skipped this video to here. I don't like cutting out videos. I like them raw and stuff, so just keep it how it is. Okay, back to the video. So hash maps is all of one, right? Better than arrays and linked lists. It's faster. The way that the keys work is the key to value. The value is okay. The key is like 0, which is the index. And okay, that's where we are right now.
And occurs when a hash function tries to assign a piece of data to an already used index. In this case, the hash function has to have some efficient way to reassign this data to a different, non-used index.
I see.
Hash functions are a bit outside of the scope of this video, and in almost all modern programming languages, hash maps are already implemented, so you don't have to worry about building them yourselves. The one thing you should know about hash functions, however, is that once they map data to a key, they cannot change this key. This means that any key in a hash map must always be immutable. If you try to assign a mutable type of data as a key, such as an array, you will get a type error that says unhashable type. If you see this error, it means you tried to assign a mutable data type to a key. To fix this, simply convert the data type to something that is immutable. As we got the error from using an array, our solution would be to convert it to a tuple.
This is your brain when you're struggling to focus. And this is your brain when you're in the zone.
Which makes it immutable. Now, this tuple can be used as a key. Hopefully it's all coming together, and you can start to understand why hash maps are efficient. If we used an array for our capital city to country scenario, we would have to make something like this. For a program to find a capital city, they would have to search through every single index until they reached the correct value. With a hash map, the program just has to receive the country name. From here, it can put the country name into the hash function, which spits out the right index.
Yeah, this is what I was confused about. These stupid captions. So the way the hash map works with the index, so we need the index. So index 0 is France. Index 0 is France. Okay, we could just say index 2 is Japan. So we go in database Japan, that equals index 2. But how do we get Tokyo? Is that the value of the node? Because isn't the value of the node Japan?
Without needing to go through every element in the list. It's time for us to look at how hash maps are actually implemented. In many languages, hash maps have different names. When it comes to Python, hash maps are called dictionaries, but I generally refer to them as hash maps anyways. We first create a hash map by initializing it. Let's call ours city map. We can initialize it in either of these two ways. Now, let's add our first key value pair. I want to add in Canada as a key, and have an array of cities as values. To do that, this is our syntax. Oh no, we got a key error. Why did this happen? This is a very common mistake people make with hash maps. We tried to assign the 3 cities to the key of Canada, but that key doesn't exist in our hash map yet. So we first need to initialize this key. Now we can add these cities to this empty array, and this is what our result will look like after this. Here's a neat trick. To avoid having to initialize an empty array for your keys every single time, we can use a specific type of dictionary in Python called a default dict, which will have an empty array or other type of data assigned to a key by default. Here's what the code would look like if we chose to do it this way. One of the reasons Python is awesome is because of its huge library, and this is a prime example of this. I highly recommend taking advantage of default dicts for solving coding problems, as it's an incredibly useful feature that will help you avoid unnecessary mistakes. The other major thing you should know about hash maps is how to retrieve information from them. There are 3 methods for this: .keys, .values, and .items. The .keys method returns all of the keys from the dictionary in the form of a list. .values method works very similarly, returning all of the values of the dictionary in the form of a list. And dot items is a combination of the two. It returns a list of all of the key value pairs as tuples. Here's an updated version of our city map from earlier. As you can see, it now has multiple countries and cities. If we wanted to get a list of only the cities, we could do so by calling the dot values method like this. Now we have a list of cities in city list that we have extracted 9 group anagrams. We are given an array of strings, and our goal is to return an array that groups all of the anagrams together. If you don't know what an anagram is, it does give a little explanation. Basically, an anagram is a group or pairing of words where
they all have the same letters, so 8, eat, and T have all the same letters, just misorganized for different words. Bat is by itself because there's no B in any of these words with AT in it. So what are you gonna do? So you store the first index as the lowest items in a list to the greatest.
all of the words have the same amount of letters. Let's take a look at example 1 to understand this a bit better. As you can see, we are given 6 different words in the strings array. Bat is put on its own because it is the only word in the group of 6 that has one A, one B, and one T. Nat and tan are grouped together because they both have one A, one N, and one T. And the same thing goes for 8, eat, and T. Okay, great. Now we understand the problem. How do we solve this? Your first instinct might be to think that we should go through each of the words in strings and compare that word with all the other words. So for example, we can start at eat and check, okay, it has an A, an E, and a T. What about T? Oh, they have the same letters. Let's group them together.
Honestly, if I was solving the problem, that's the way I was solving it.
Now let's compare eat and tan and go through them that way. However, if you did that, it would become incredibly inefficient as the length of strings got longer.
Yeah.
Because we have to check for each element in strings, we are checking every other element.
Right.
This has a time complexity of n squared.
I knew it was n squared.
What if there's a more efficient way of doing this? I'll give you a few seconds to stop and think about how we can go through this a bit better.
Check this out. I'm going to show you how I afforded this car. Okay, you ready? All right.
Okay, of course we need a hash map, so the only way I'm thinking is like, okay, so we have like a so we start with we make this then how will we okay, so we make this a key. My bad, guys. Eat. So what other words have EAT in it? This is a key. We have 8 and T. Boom, stored in there. Now we remove eat, 8, and T out of the input. Then we have the next word would be tan. We have tan and nat, but bat isn't. Then you make them into a list together. Then you have that as the last remaining. I don't know.
Now, we've come up with an idea for how to solve this in O of n squared time. But can we make this better? What if we could go through each element only once and check if it's an anagram from there? That would be a solution in O of n time. Seeing as this is a video on hash maps, you've probably already started thinking that we could use a hash map to solve this.
Wait,
If you're on that
what?
train of thought, you're absolutely correct. But how are we actually going to be using this hash map? I'll give you a few seconds to think about that.
Okay, another idea. So no, I'm lost. My idea's gonna be wrong.
If you
anyway.
need more time, pause it here, but now we're going to go through the solution.
Please.
Basically, we want to go through each word in the strings and check if its combination of letters is already a key in the hash map. So, we would get to each and check, is the combination of 1A, 1E, and 1T a key in the hash map? If it is, add this word, eat, to the array associated with that key. Then let's check T.
Yeah.
Is-
So the first index is 0. Is if the first index key, if that key's list, if there's anything, if there's nothing in that list, append that first EAT into it. Then see if T has the same letters as EAT in the first index. If it doesn't, then we'll append that to the second index, but it does, so you append it to the first index. Tan doesn't, TAE, it doesn't have a TEA in it, it has a TAN, then we append that to the next index key. If not equal, well, so we just gotta see if it's not. I'm trying to see the pseudocode in my head. I'm seeing where the vision is though. I'm getting it. And that's O of 1. Boom, okay, I think I get it.
E,
Just I don't know how to
A,
implement
and T
it.
already in there? Yes, it is. We just saw it. So now let's add a T as another value in that array associated with that key. This process will continue until we built out a full hash map. From here, all we have to do is go through each of the values in the hash map and
We just learned that. Yeah, so dot values, we don't need the keys because the keys will be the index and items would just be everything. We just need the values. And that should return
append
the
them to
value.
our array.
Yeah.
So let's get started on the coding process. The first thing we need to do is actually create our dictionary or hash map. I'm just going to call mine anagram map because this is kind of the simplest way of understanding what it does. We also know that our result has to be an array. So we're going to be creating a result as an empty array for now. We'll be adding values to it later. The first thing we need to do is go through each of the words and check if it's an anagram, and for which anagram it is, we need to add that to the anagram map. So we'll say for S in strings, so for each string. Now, how do we actually check if a word matches a key in the anagram map?
Oh, yeah,
We can always go through each word and count all of the letters,
Yeah.
but there's actually a simpler way.
How?
In Python, you might be familiar using the sort
My work is easy because I use ClickUp. Here's how I keep track of all my tasks. I start by brain dumping everything I need to.
method, which allows you to sort a list of numbers either in ascending or descending order. But you can actually use the sort method on words as well. If we use the sort method on a string, it will sort that string in alphabetically increasing order. As you might be starting to find,
Wow. I get it. Dude, that's so... A-E-T. No, A-E-T, right? A-E-T. There's no A, yeah, A-E-T is not a word, but so, sorts the numbers in lowest to greatest, right? If you do that with letters, it sorts it by, damn, I did not know that. So that means that we just need to check if S is sorted, then we check the next word, sort, TEA, and it's gonna be the same as that one. Boom, it is TANANT. Damn. Wow.
Find out now, this is how we're going to solve this. For each of these words, if we sort them in alphabetical order, all of the anagrams will end up being the same combination of letters.
Yeah.
So in this case, with ate, eat, and tea,
They'll be all the
they
same.
will all be resorted as A, E, T. This will be our key in the anagram map. Now, once we have fixed...
I don't know if this is a way. Tell me in the comments below if you're watching this video. Just say thumbs up or something. But can you sort the input already? Can you put strs dot sort, and does this sort every which one? You know what, bro? Why don't we shut the fuck up and actually try it ourselves? So if we put stirs is equal to, we need a list, 8 10. Bro, I don't even know what other words. Wait, what the fuck? Oh. 10. I don't fucking know, man. Okay, cool. Let's just do these. If I do x is equal to stirs dot sort, is it sorted? Shit, I don't know. I don't think I've used sort. How to use sort? My list does sort. Oh, okay. So it's just that we just get that dot sort, and we print my list. So okay, can I do this? Then I do x dot is it sort or sorted? Sort, and then we print x. So this is dog ass. What I have to do stirs dot, am I an insert? Stop that. Stirs strings dot sort. Does that work? Ain't shit working, bruh.
figured out what the sorted version of each of these words is, we know what the key is. All we have to do
It's like sorted. It's not sorted then? Keeps giving me the, yeah, I don't know.
is add the original unsorted word to that key. So we are first going to sort the string, and we will call ours sorted S, which is going to be a sorted version of that. And then we are going to be adding.
So you have to get a value first, which makes sense. Which makes sense. should be AET then. Ow. Bro.
That as a key into our anagram map. So, anagram map, and our sorted S is going to be our key. For this key, we want to append the original word onto the array. Now, there are two mistakes here, and I hope you caught on to both, because they are the two mistakes we talked about.
Sorted S is equal to sorted S equals sorted S with an anagram. Anagram map. We're gonna sort that key
Earlier in this video.
if it's in
The
there.
first thing is, we don't have this key initialized in our anagram map,
Right.
so we are going to get a key error. If you remember the way around this, we are actually going to be using a default dict. So, we're going to come up here, and we're going to say from collections, import default dict. We're now going to be replacing the Python standard dictionary here with a default dictionary, and the type we want to set it to is list. This just means that for each key that we're going to be adding to our anagram map, we want the default value to be an empty list. You could do the same thing with integers, strings, etc. It's just in this case, we're going to be using lists because we're appending things to them. Great, that's mistake one. Mistake number two is that we are using sorted S.
Connectivity through Spectrum is vital, provides us with
as our key. However, when you run the sorted method on a string, you're actually getting a list object back. And as we talked about earlier, lists are mutable, and mutable data types cannot be keys. So to get around this, what do? We simply need to convert this list into a tuple, which is an immutable data type. After we have done this, our anagram map will come together. Just to see what that looks like, let's print out our anagram map. As you can see, it is a default dict where AENT has these three words, ANNT has these two, and ABNT has bat. Great, now that we've done that, we're really close to the solution. All we need to do now is just add all of these values and append them onto the result.
So
To do that,
anagram
we wanna
dot
go to each value
items.
in the hash map. So we're going to say for value in
Anagram
map
map
dot
dot
values,
values.
which anagram map dot values will give us a list of the values. And
Append
for
it
each
to
of these
the
values,
list.
we are just going to append them to the result.
Yeah, result. Sorry.
After we've done that, all we have to do is return our result, and when we call the function, exactly, just like that, we solved it.
Makes
Now, as you
sense.
can see, the output and expected answers are actually a little bit different, but that is because the question says you can return the answer in
Any
order.
order. Remember I said bat there. Why, I guess that doesn't matter. You gotta read the instructions, brother. Alright, that video helped a lot. I'm starting to understand it. Now we have to understand the way this course works is how does like a hash function, I guess, build a hash function. Then the next shit I think is just like, what, learn how to do insert, get, resizing, linear prob. I think that's like insert or something right there, right? Yeah, insert and get. It's like a problem. Oh shit, we're doing a problem. Alright, let's see how much we can do. Hopefully we, no, let's finish this shit. Hash function, let's build a toy hash map in Python. In the real world, you'll always use the built-in Python dictionary. If you need a hash map, however, just use a dictionary. It doesn't teach us about what's going on in the hood. Assignment. As it turns out, the binary search tree was overkill for profile lookups on locked-in website. You don't need any fancy order, traversal, or range queries after all. And because locked in is such a business failure, our CEO's words, not mine, we can store every user in memory. No need to save them to the hard drive. Let's build a hash map. We'll use the strings usernames as keys and map them to user objects. Okay. So complete the hash maps key to, yeah. It should take a key string as input. Take a key as input. What? I'm just stuck on this shit. What does it mean key string as an input? Isn't the fucking key already given? This is just math, bro. Take a key string as input. Bro, I swear to God, it gives us the fucking key. Okay, it gives us the key. Calculate the sum of the Unicode value. Now it's talking about fucking values. Where's the value? Where? It doesn't give you. Well, the key is key. I'm lost. I think I'm brain farting because this is easy. Think about the input. It's like a string Alice or Bob, right? So what the fuck you want me to do about it? Bro, take a key string as input. That's what I'm fucking. Bro, I thought I'm tripping, bro. I thought I'm going insane, man. I don't know what the hell is going on in my head. Input, like, what? Calculate the sum of Unicode's value. Calculate the sum of Unicode's value of all characters in the string using. So, what is it? How do you use ORD again? So, sum is equal to ORD the key. Total is equal to 0. So 4 num in. So 4. So it's 8 to. I need to split it. Let me mess with some stuff. So let's just say that the key is equal to naughty, and then we want x to equal ORD the key, and if I print x, okay, I'm using ORD wrong then, I guess. ORD A, that's what we need, right? ORD, and this gives you this. How do I use ORD? Bro, I want to crash out, but or expected a character but string of 5 length of sum. A character? Oh well, it's expecting this, huh? What? What do you mean character? Isn't that what the fuck this is doing? Okay, let me just do one thing real quick. let me just try to solve this shit. So if I have num is no, if I get the if I put ord x is equal to ord, oh my lord. What do you mean character? It is a fucking character, bro. What do you mean? This is a fucking character. Character like one character? Oh, wait. Fucking not the string. No, 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 no. Wait, no, no, no. My logic has to make sense. So for character in character, we're getting this. So some. Right, the Unicode num. So if I do Unicode num, we get 100, whatever. 100. So we have to outside the for loop. So sum is equal to 0. Sum plus equals the Unicode num. Right, we get calculate the sum of the Unicode values of all characters in the string. Okay. Mod the sum by the size of the hash map to get the index, which should be int. Okay, mod the sum. So calculate the sum of the Unicode. Okay, we did that. Mod the sum of the size of the hash map. Okay, let's just make sure everything's right before we move on. I just want to be correct. What? Yeah, but that's true. That is true. That's me. But we're doing it right? Okay. So modding the hash map size. So the size of a hash map. Can you get the size of a hash map? Yeah, just the size function, right? So we get 3. So what are we doing? I don't know. So it equals, we get, so sum mod the size of am I supposed to put the, I think I know the problem. Let me just, yeah. I see, I would have never guessed this. The length of the hash map. It's not a hash map. Yeah. See, they don't teach you that shit. They don't teach you that shit. So, boot.def for the great explanation of when to use hash map. Like, people have prior knowledge of when to use that method, bro. So fucking. Let me see what the holy shit, they just did this shit in 3 lines. So sum for C and key, sum plus over key. So sum. What did I do? Oh, I did not need this Unicode shit then. I don't know. Makes sense to me, bro. Get off my back. Okay, insert. Now that we have some building blocks for a hash map, we need to wait to start inserting values. Assignment. Complete the insert method. It accepts a sorting key with an associated value, in this case locked in user records. Convert the incoming key to the appropriate storage index using your existing hash. I'm lost. Yeah, for sure gonna need help. Insert. So, how the fuck do we insert? We insert a string key and the value. So then we have to make the value. We have to make what the index be the. So key value. What do you mean none? The resulting structure should look like something like this, with key values at some positions and empty slots at others. Indexes with an entry will contain a tuple, and empty indexes will contain none value. And empty indexes will contain none value. But why would this be the third index? Why would we skip these? Oh, sorry. Okay, moving on. Please explain what is going on so I can solve. So what insert method should do? Use the hash function. You've already built the key, which takes in the key like Modi and returns a number and then already write whatever. So the first thing you do is index equals so what the fuck? This dumbass shit, give me the fucking code. Fuck. I don't know what the fuck. So what the fuck is going on? Wait, so first thing you'll do is this, the index. We have to self dot key to index. That's this. Right? That makes sense. Oh, dick. So the index is equal to self dot key to index. We have to put the key in here. Then after, we have to store them as a tuple, and then, well, make them as a tuple, then store them. So we have to make them as pairs, which would, to make a tuple is what? So the key, then the value, then at the end we have to insert it, which so self the hash map. I guess. How do you do it? I equals self the hash map. The index stores this. Alright. Now that we insert our users and their records to our hash map, we need a way to retrieve the information when requested. Complete get method to take a key. Well, so now that we can insert our users and their records in our hash map, we need a way to retrieve that information when requested. We need a way to retrieve the information when requested. So complete the get method. It takes a key, a string, and returns a value location. Not thing. Use the key to index method to find the correct index to look up the self.hash map. If that value doesn't raise a so if it's in there, see if it's in there, but this is just like, I'm building the motherfucking hash map, bro. I'm not even using it. I don't like that. Bro, I don't like how it's doing that. That's so like ass. So just like insert, you'll use so you do that. Then what this does right. Alright, but the thing is, if that slot is none, if slot is none, then we raise exception. Sorry. Key not none. Fuck. Oh, I'm not returning it. don't want to do this. I don't want to. I don't like this. If the slot 0 equals the key. Fuck this, bro. I don't like this. I don't like how this shit, bro. I'm building the goddamn like hash, like this shit, bro. Like it's so bullshit, bro. So ass. What happens in our toy hash map if A, B, and BA are both? Okay. Okay. Now this I'll read because this is important. Now this shit I'm building it, bro. What the fuck I need to build a hash map for? I need to use the fucking hash map. Hash maps are awesome. They're simple to use and have an average computation cost of 0.1 for and deletion operations. We'll start by building a balanced red-black tree, and then once we have that, we can build. Just use a hash map. Just use a hash map. In Python, that means dictionaries. In Go, that means maps. In JavaScript, it means object literals. The point is, if you need an in-memory key value stored, hash maps are awesome in every language. Properties of a good hash map: fast lookups, unordered, no ranging, collision resistant, hashable keys, efficient. Okay, our toy hash map. It has a few big problems, but at least it's valuable for understanding because it doesn't resize when it gets too full and glitches. Okay, what happens in our toy hash map if A, B, and B are? No. Yeah. That makes sense. Okay, fuck this. I'm gonna do a problem on my own. Get off stream, bro. I mean, video. Alright, guys. I don't know. I understand hash maps. I just never implemented it. I'm creating a why the hash map works. So I don't know. I didn't like it, but it's okay. Thank you guys for clicking the video. See you guys later. See you guys tomorrow.